Okay. Okay, we're here.
92, 94, and 99.
Yeah, so we're doing 3 lessons today, but they're all the same type of problems. They just add a little bit more each time. So I'm not going to show you the way they show you in the book because I think it's really complicated and that there is a much easier way to do these. If you really want to learn the way in the book, then read it over and ask me questions on Wednesday, and I'd be happy to spend all day Wednesday doing this again the hard way, if that's what you really want. I don't think you really want that, so let's just move on to the easy ones. So let's talk about distance problems just in general, okay? Distance problems basically goes along to how fast something's been going and for how long, okay? So if I were driving at 60 miles an hour for 2 hours, how far would I have gone? 120 miles. You multiply the speed times the time and you get the distance. Notice that the hours cancel out, right? There's an hour on the top and an hour on the bottom. Right? Make sense? We follow so far?
Yep.
Okay, so the key equation to remember for this is distance equals rate times time. Okay, that's it. That's the hardest thing to learn for this lesson. D equals RT. Yes. And I'm going to pause this for a minute. UPS guy just showed up, so I'm going to see what's here. Enough of the creep. Any which way. Okay, so D equals RT. That's the challenging thing of this. It's the only thing you have to memorize, really. And then the trick to these fun equations that make them a lot easier are 6 little boxes. So you just need to set up your 6 little boxes. And so notice I made a table, and the table has 6 boxes. When you write it down, all you have to do is just write 6 boxes. You don't have to, draw the lines up the top and out the side, just 6 boxes.
Oh, yeah.
Pretty easy, 6 boxes. At the top, write distance, rate, and time, right? Distance equals rate times time. So that's the part you have to memorize, is distance equals rate times time, okay? And then usually these problems are done by comparing 2 different things. So you do a thing 1 and a thing 2. Then you figure out how the distances are related and you make an equation based on that. Okay, so that's the general framework of these problems. Let's look at an example here. So Bella was bored when I decided to walk to the store to get ice cream. It's 2 miles away. I walked 4 miles per hour. After 15 minutes, Bella decided she really wanted ice cream, so she ran 10 miles an hour to catch up. How long had I been walking before she caught up? So,
15 minutes.
no, you left 15 minutes later than me. You hadn't caught up after 15 minutes.
Oh.
You were just starting. So that's actually a good idea. Let's think about how this goes. After 15 minutes, I had been walking for some distance and Bella was still at home. Then I continued walking at that same 4 miles an hour and Bella ran at 10 miles an hour. So how long did it take for her to catch up? That's what this is asking. That's what these kinds of problems talk about. So first of all, write in your table the variable of what you're looking for. So in this case, it's how long had I been walking before she caught up. So it's the time for me. So write T there. I put hours just to keep the units the same. You really only have to write the T there, okay? So that's the first step. We're filling in all 6 boxes. That's how you start these problems. Write the 6 boxes and then fill them in. So the first one, how long had I been walking before she caught up? T. Okay. Then how long is Bella? Well, Bella's walking is 15 minutes less than mine, right? Because she started 15 minutes later than I did. Got it? Now we're talking about miles per hour, so we have to talk about hours. 15 minutes is 1/4 of an hour or 0.25 hours.
15 minutes can save you 15% or more on car insurance.
It could, but not if you're going to run to get ice cream.
True.
So her time would be T minus 0.25 hours because she is running 1/4 of an hour less than me. Does that make sense? This is the hardest part of these whole tables, is getting the variable part set up. Okay. The next thing is we figure out the rates. Those are both given. My rate is 4 miles an hour and Bella's is 10 miles an hour. Okay, write them in the table. Then multiply rate times time to get distance. So 4 times t is 4t. 10 times t minus 0.25 is 10 times the quantity, t minus 0.25. So those are the distances. Any part of this table confusing? You guys get that so far?
I lost at Bella.
Go put the chicken away.
Listening.
Okay, but
Okay, so really, I don't get how you got the time. I get how you multiplied time times rate to get distance, but I don't.
okay. So I'm looking for my time.
Yes.
So just make that a variable. You could call that X. You can call that G. You can call it whatever, right?
Okay. Yes.
Okay. So if I've been walking for that many hours, how many
Mhm.
hours have you been running? Well, you started 15 minutes after me. That means you've been running less time than I have.
Oh. Uh-huh.
Okay. Now we're talking in terms of hours. So 15 minutes is 1/4 of an hour.
Mhm.
So we're going to take the amount of time that I've been walking and subtract 1/4 of an hour, 15 minutes. That's the amount of time you've been running
Okay. Yes.
because you started 15 minutes later than I did.
Yes,
Okay. You
That-
understand now?
that makes sense.
Good. Mark, you follow?
Yep.
Rosie, you follow?
Yeah.
Okay. So, like I said, 6 little boxes. That's it. Set them up. Now, what happened with these distances? We're asking the question, she caught up. When Bella caught up to me or catches up to me, that means our distances will have been the same, right?
Mm-hmm.
Right? That makes
Mhm.
sense? That's what we're looking for, is at what time is our distance the same, right?
Yes.
Does that make sense, Rosie? You look confused.
Oh yeah, I'm fine.
Okay. Okay, very good. So we finished the table. Notice that the 2 miles in this case doesn't matter. It says that it took 2 miles. The ice cream store was 2 miles away. It doesn't matter that it was 2 miles away. It asked how long until she caught up. Okay.
But we still don't know how long.
Well, we do know that the two distances are equal. That's what meeting is.
Yes.
So we can make an equation. 4t equals 10 times the quantity t minus 0.25.
Okay. Yeah.
Right? Because the distances are equal, set them equal to each other, and then just solve that little equation for t. These generally are pretty easy equations to solve. So 10 times t is 10t, and 10 times 0.25 is 2.5. That shouldn't be 0.25. It should be 2.5 in the second round. Yeah, I get it right. The next one down. Bring the 2.5 to one side and the 4 to the other, and you get 6t equals 2.5, or t equals 0.416 repeating. Okay, do you all see how we got t here?
Mhm.
Once
Yeah.
you have your table set up, you just solve it like an equation that we're used to. Right?
Yeah, I mean, and these are not hard equations. You all follow how the equation was solved?
Yep.
We've been doing these for months now. Okay, good. Now, t is in hours. Let's talk about minutes, to get it to make it a little bit more sense. So you multiply that 0.416 repeating times 60. If you just used your calculator, you did 2.5 divided by 6, it would already be there. Just hit times 60 and you get 25. So that means it's 25 minutes. So what is 25 minutes? It means I've been walking for 25 minutes. And
Yep.
since Bella started 15 minutes after me, she had been running for 10 minutes. That's when she caught up. That's when our distances were the same.
Okay.
You got it?
Yep.
Any questions, Mark, Rosie?
Nope.
Nope.
Okay, that's it. That's what these are. Sometimes we ask different questions and get different answers, but for the most part, this is how it comes up. So let's look at example 92.1 in the book. It is on page, I guess, 384. So look at how much fun it looks to solve this the way the book does. We have DE and RE and TE and F's and all the rest of it. So yeah, exactly. This is much easier to do it this way. So let's read through it and fill in our table, okay? On Tuesday, the express train made the trip in 12 hours. On Wednesday, the freight train made the same trip in 16 hours. Find the rate of each train if the rate of the freight train was 15 kilometers per hour less than the rate of the express train. Okay? So what are we looking for? We're looking for find the rate of the freight train. I'm sorry, find the rate of the express train. Find the rate of each train. So you could do either R is one or the other. In this case, let's make the R the express train, okay? And it said the freight train was 15 kilometers per hour less than the express train, the rate. So it'd be R minus 15. You guys get that middle column? That's what we did first. Then find the times. So the express train, it took 12 hours. The freight train, it took 15 or 16 hours. Yes. Right?
Yep.
Just says it in the problem, right? Good enough?
Multiply.
Okay. Then you just multiply it across. 12 times R is 12R, and 16 times the quantity R minus 15 is 16 times the quantity R minus 15, right?
Then you set it up like
Now, since they went the exact same distance, it means that distances are the same, right? They went the exact same route. So the distances are the same. So set the distance equal to each other. And then solve that, and you get R equals 60. Got it? And now what is R? R is the rate of the express train. So to find the rate of the freight train, because it asks you to find both, you have to subtract 60 minus 15, which is 45. Any questions?
One question.
Yep.
Why is it subtract 15? Oh, because is that
Because it says here, the freight train was 15 kilometers per hour less than the express train.
okay?
The
yes,
rates.
So you have to take away 15.
Yep. Okay, now let's do 92.2. Okay, so what are we talking about here? In 92.2, so hiking and riding, right? So the members of the girls club hiked to Lake Tenkiller at 2 miles per hour. So they hiked at 2 miles per hour, right? Mr. Ali gave them a ride back at 12 miles per hour, right? See, I'm filling in the table. Fill them in on your own, as you're writing this kind of stuff down.
Yep.
Find the hiking time if it was 5 hours longer than their riding time. So hiking time would be T. So T plus 5 is hiking and T is riding, right? Does that make sense?
Yeah.
Because it took 5 hours longer to hike than it did, or 5 hours longer, right? We're good. Now multiply. So that is 12T. And that is 2 times the quantity, T plus, T plus 5. Right?
Yep.
We're good? Yeah?
Mm-hmm.
Everybody follow that? Again,
Yeah.
making the table makes this easy. And then, since they went there hiking and came back driving, the distances are the same, right?
Yep.
So this is the same distance problem. So we just set them equal to each other. So 12t equals 2 times the quantity, t plus 5, or, oops, come on. Where am I? There we go. Okay, so that's 12t equals 2t plus 10, or 10t equals 10, or t equals 1, right? That means it took 1 hour to ride back and t plus 5 or 6 hours to go there. Right? Does that make sense?
Yeah.
Yeah.
Okay. And then the second part of the question is how far was it? So we could just substitute t back into any of or either of those distance equations to find out the distance. I'll just do the bottom one. 12 times 1 is 12. So it was 12 miles to get there. Got it, Mark?
Yep.
Got it, Rosie? Dude, I mean, these aren't hard. Any questions or challenges?
Nope. These are actually easier than I thought.
Okay, let's do 92.3 then. Okay, what are we talking about there, Rosie? Read the problem while I'm erasing.
Is this in the book?
Yeah, we're on page 386.
Okay, I don't have the book with me. Should I do that?
Oh, okay. Go for it, Mark. You tell me then.
What is it? Which problem?
93.
92.3.
All right. Durant drove to the Oasis in 2 hours, and Maddill walked the Oasis in 10 hours. How far is it to the Oasis if Durant drove 16 miles per hour faster than Maddill walked?
Okay. So what do we got? Tell me what to fill in, Mark.
So Durant's rate was 16 miles an hour.
Okay.
Oh wait, no, never mind. So Durant, his time was 2 hours,
Time was 2 hours,
and the other dude's was 10.
10 hours.
Um, we have to figure out all the other stuff from there because we don't know how far they walked or drove or the distance. So
Okay. So let's let R be Madill's rate. Okay. What's Durant's rate?
16 miles per hour faster than R.
Right. So R plus 16. Right?
Mm-hmm.
That makes sense?
Yep.
Then how do we get distances, Mark?
I don't know.
Multiply the rate times the time.
Distance equals rate times time.
Okay.
So multiply.
So it's R plus 16 times the quantity 2.
Yep. Just like that.
Mm-hmm.
Okay. Multiply the bottom one there, Mark.
R times 10.
Right? Right?
Yeah.
Yep. Okay.
And they're equal distances. So I just set it up.
Yep, exactly. Equal distances. So how do we set up the equation, Mark?
Not sure.
Okay. We know that the two distances are equal. So our equation just sets them equal to each other. So how would I write that?
I don't know.
10R equals 2 times the quantity R plus 16.
Does that follow, Mark?
Yep.
You understand that?
Mm-hmm.
The two distances are equal, so you just put an equal sign between them. That's it. So now help me solve it, Mark.
Do you distribute the 2?
Okay.
2R plus 32.
Very good. Then what?
Subtract 2R from both sides.
Uh-huh.
8R equals 32.
Okay.
And then R equals 4.
Very good. Okay, now what does it ask there? What's the question?
How fast? Oh, wait, no. How far is it to the oasis?
Right. So what is how far? How far is which one? Distance, rate, or time?
Distance.
Distance. Okay, so we know R. So how do we figure out what the distance is? Well, what's the distance box for Madill in the 6 friendly boxes?
10R.
Right. So do we know R?
No.
It's 40.
Do we know
Wait,
R?
oh, yes, we do know R. It's 4.
Right. So what do we get then for distance?
40.
Very good.
Okay.
Did you follow that, Mark?
Mm-hmm.
I know these are a little bit tricky, so that's why I'm making you guys do some.
Okay.
Rosie, did you follow that?
Yeah, I think so.
Okay, good. Let me erase this one and we'll do another practice. Okay. Okay, so let's do practice A. We have Candide and Pangloss.
Walk to the side of the disaster in 9 hours. The next morning, they jogged back home in 3 hours. How far did they jog? How far did they jog if they jogged 4 miles per hour faster than they walked?
Okay. So actually, we're not talking about, because they did it together, so we're not splitting them up. We're doing walking and jogging. Right? See?
Mm.
So it says that they walked to the site of the disaster in how long? 9 hours. So where would I put that, Rosie?
You said they walked for 9 hours.
They walked to get to the site of the disaster in 9 hours. It took them 9 hours to walk there. Where would I put that 9 hours?
Under rate, right?
Nope. Rate is a speed.
Oh, yeah, distance, right?
Nope. Distance is a.
Fine. Yeah, because distance is, okay, I'm getting these all mixed up in my head. So rate,
Okay.
rate is how fast they went, right?
Yep. Time is how long it took, and distance is how far.
Yeah. Okay.
Okay. So we got that. Let's see. The next morning, they jogged back home in 3 hours. Where would we put that?
What?
Said the
Okay.
next morning, they jogged back home in 3 hours.
Next one. Okay, so then that would also be under time, so 3 hours.
But where? Which line?
On the bottom line, like by
By jogging, right? Very good. How far did they go? How far did they jog if they jogged 4 miles an hour faster than they walked? So that's our rates. 4 miles an hour. They jogged 4 miles an hour faster than they walked. So what would you put here in either of those boxes?
So you put 4 miles an hour under rate next to jogging, right?
So not quite 4 miles an hour, because it's not saying they jogged at 4 miles an hour. It's saying they jogged 4 miles an hour faster than they walked.
Oh. So, wait, how would you do this? You have to.
So we don't know how fast they walked. So let's just do an R there for walking, right?
Mm-hmm.
And now, how would you write 4 miles an hour faster than how fast they walked?
Would it be like 4 miles times 3 hours or 9 hours or whatever?
No, even easier than that. Just 4 plus R.
Oh, yeah.
Because R is how fast they walked. 4 plus R is how fast they jogged.
Mm-hmm.
Okay. Now, how do we get the distances?
By doing you to multiply.
Yep. So go ahead, multiply for me.
Wait, what am I multiplying again?
Rate times time equals distance.
So it's wait, that would be 12 plus R. Is that how you do that?
Not quite. You have to multiply the whole thing in parentheses. So 3 times the quantity,
Oh, yeah.
4 plus R, right?
Uh-huh.
Why
Yeah.
don't you do that? What's the top one then?
So 9 times the quantity R. Wait,
Yep. And so what is that simplified to?
just 9R, right?
You got it. You follow there, Rosie?
Mhm.
Okay, these are a little complicated. Make sure to
Yeah.
ask questions if you have any. So
Okay.
now they went there and they came back the exact same distance, right? So that means the two distances are what?
Equal.
Very good, Rosie. And so what equation would you do to make them equal to each other?
I don't know.
Well, you have two distances. What are the two distances that you have in the table?
9R and 3 times the quantity 4 plus R.
Right. How would you write it so that those two distances are equal to each other?
Well, they aren't equal. So how do you write
Well, they
that?
are. They are. That's what the problem says.
Oh,
They
Oh.
walked one way to get there and then they jogged to get back. So by reading the problem, you know the two distances are equal.
so it's just 9R equals 3 times the quantity 4 plus R.
Exactly.
I thought it'd be more complicated than that.
No, that's it. That's why I'm making you guys do these because it's easy to listen to me talk through them, but then to do them yourself, you get these little epiphanies. Okay, so now how do you solve that equation?
You have to just solve it.
Right?
Right.
What would you do?
It would be, so you have to do 3, so that'd be 9R equals 12 plus 3R.
Uh-huh.
So then you have to subtract 12 from both sides and
Now leave the 12 there. Get the 3R to the other side.
oh, okay. So then you subtract 3R from both sides. Right? So then
Yeah.
you have 12R. Oh, yeah, right?
No, 9R minus 3R. You're subtracting it.
Oh, yeah. So then you have 6R equals 12.
Uh-huh. And then what?
And divided by 6 on both sides. And so that is R equals 2.
Very good. Okay, so that is what R equals. R equals 2. How far is it to the oasis? So it's asking distance.
You
What?
just plug 2 back into one of the original equations. It's 18.
Oh, yeah. How far did they jog? Yeah, how far did they jog? So what do we get?
18.
So Rosie, we have two different distances. Pick one.
The walking distance,
Okay, which is?
9R.
And what did we just say R equals?
2.
So
Oh, so
what's the
9
distance?
the distance is 18.
Bingo.
Okay, that makes sense.
Okay,
Mhm.
cool. So that is lesson 92. Let's go back and let's do 94 now. 94 is the exact same type of problem. The only difference in 94 is that the distances aren't the same anymore. Now we're talking about distances that add together to get something else. Okay. So again, the only difference here is how to set up the equation after the 6 little boxes are filled in. Okay. So let's fill in the 6 little boxes first. A southbound bus left Fort Walton Beach at 9 a.m. 2 hours later, a northbound bus left the same station. If the buses traveled at the same rate and were 352 kilometers apart at 2 p.m., find the rate of the buses. Okay. So in this case, the distance isn't the same. They're not traveling the same distance, but we know how far apart they are at the end of it. So let's see what we can get together. Okay. So in this case, it says the buses traveled at the same rate. We don't know the rate, but it's the same. So just write R under both boxes for rate because they were the same, right? Make sense? Okay. Now, the first one left at 9 a.m. and got there at 2 p.m. How many hours is that?
5 hours.
5 hours. So bus 1 is going 5 hours. 2 hours later, another bus left. So how long did that one go?
3 hours.
3 hours, right? You got that? See? 5 hours and 3 hours. You write that for bus 1 and bus 2. Okay. Now we need the distance. To get the distance, you multiply rate times time. So 5R for the first bus and 3R for the second bus. Okay.
Mhm.
You guys figure out, or you understand how we figured out, we filled out the table. Now it's saying that the question is if the buses traveled at the same rate, were 352 kilometers apart at 2 p.m., find the rate of the buses. Okay. So if they were 352 kilometers apart and they went in opposite directions, that means that the distance the first bus traveled plus the distance the second bus traveled equals 352. You guys get that?
Yeah.
If we're standing back to back and I walk 10 steps and you walk 5 steps, how many steps apart are we? We're 15 steps. You see what I mean?
Yeah.
Because they're going opposite directions. So you just add them together. So it's pretty simple. 5R plus 3R equals 352. Take the one distance and add the second distance. You get 352. So then 5 plus 3 is 8R, and then just divide both sides by 8. So R equals 44. So both buses were traveling at 44 kilometers an hour. That makes sense? Any questions?
Yeah, this is pretty easy.
Yeah, this is pretty, yeah.
Okay, let's try 94.2. Bella, why don't you tell me what to fill in for this one?
A train starts from Toledo at 11 a.m. and heads to Mackinac, that's what I meant, 332 kilometers away. At the same time, a train leaves from Mackinac and heads from Toledo at 35 miles an hour per kilometers per hour. If the trains meet at 1 p.m., what is the rate of the first train?
Okay, so tell me how to fill in the box.
Okay. Well, Mackinac and Toledo are 332 kilometers apart.
So that actually doesn't go in the box.
Okay.
The box is just each train. That'll help us set up the equation afterwards.
Okay. All right. So, the first train leaves. Okay, sorry. The second train heads for Toledo at 65 kilometers per hour.
Okay, there you go, 65 kilometers per hour.
It doesn't give us anything else.
Yes, it does. It tells you how long.
Oh yeah. The train from Toledo is 11 a.m. So it's a 2-hour difference.
Okay, so the first one is 2 hours.
They both are because they leave at the same time and they meet 2 hours later.
Ah, okay. Two hours. Okay, and so what's the question? What's the rate of the first train?
Yeah.
So that's would be an R. Right?
Yeah.
Okay, then what? How do we finish the table?
Okay, that's for the distance of the first train. That is 2R. Oh no.
Yeah.
Okay, kilometers. And then the next one is 165. Give me a second. 130.
Very good. Now, what it's saying is that they started out here and they traveled on the same track, right? So they were traveling towards each other, right?
And they blow up at 1 o'clock.
And it's when do they meet? So when they've met, that means that both of them have covered the distance, right? So the entire distance between the two cities was covered by one train or the other.
Yes.
Does that make sense?
Mm-hmm.
So it's the same setup as the last one. So what's the distance between the two?
332 kilometers.
And so 2R plus 130. 2R plus 130 equals what?
332 kilometers.
332,
Okay.
right?
Yeah.
Because the distance the first train traveled plus the distance the second train traveled equals the entire distance between the two cities. Because one left the
Yeah.
first city, the other left the second city, and they kept going until they touched right in the middle. Does that make sense?
Mhm.
Yeah? Okay.
Yeah, so
let's solve that.
100
2R equals 202. And then R equals 101. Okay. So train 1 was traveling 101 kilometers per hour. Train 2 was traveling 65 kilometers per hour.
Mm-hmm.
Make sense?
Mhm.
Yep. Okay. That's how we do those. Let's do 94.3. Mark, why don't we do that? You tell me what I
Okay.
need to write.
94.3.
Yep. Page 393.
All right. The ships were 400 miles apart at midnight and were headed directly towards each other. If they collided at 8 a.m., find the speed of both the ships if one was 20 miles per hour faster than the other. So,
How would I fill out the table?
in one of the ship's rates,
What?
write R plus 20, and in the other, write R.
And that's because one ship was 20 miles an hour faster than the other. So that's
Yep.
right.
They both were out for 8 hours before they collided.
8 hours. Very good.
Man, what is it with math books and collision?
And then distance is rate times time. Right?
Yep. So how would you get rate times time?
So
Or what would you
you
get?
get 8R on the top,
Yep.
and then you get 8 times the quantity R plus 20,
Very good. Okay.
and then you'd get for your equation. Oh wait, no, they are 400 miles apart.
Right. So that means by the time they collided, they've gone a total of 400 miles,
Yeah,
right?
200 miles each.
Well,
Wait,
no, not 200 miles each because one of them's going
one's
faster than the
moving
other.
faster. Yeah, okay.
So the one that goes faster is going to get to that meeting point sooner. It's going to cover
Yeah.
more distance, but either way, together they cover 400 miles or kilometers or whatever miles.
Yeah.
So how do we do this?
So it would be 8R plus 8R equals 160.
Not quite. 8R plus 8 times the quantity R plus 20. So those are the two
Oh.
ships.
Okay.
Equals, how many miles apart were they?
400.
400. So that means
okay, I get this.
over the course of the 8 hours, the first ship went 8R miles. The second ship went 8 times the quantity R plus 20 miles. And since they crashed, that means that together they covered that 400 miles.
Yeah.
Okay. Does that make sense, Rosie? Yeah. Okay, good. So now let's do this. 16R plus 160, right, Mark?
Yep.
Then what?
Subtract 160 from both sides.
Equals?
240.
Yep. And R equals?
I don't know the math, but let me look.
15.
15. Okay.
And it asks, what's the question was saying? Read the question again.
The ships were 400 miles apart at midnight and were headed directly toward each other. If they collided at 8 a.m., find the speed of both ships. If one was 20 miles an hour faster than the other. So we need to
Okay,
find
so that means we found the speed. What is R then?
R is 15 miles an hour.
What does that mean? That's
Um,
the speed of, look back at your table. Where is R?
and rate.
For what? Ship 1.
Yes.
So the question asked, find the rate of both ships. So how would you find
Okay.
the other rate?
So you'd add 15 miles an hour to 20. You'd get 35.
There you go.
And the first
So
one's
one
15.
ship was going 15 miles an hour. The other one was going 35 miles an hour. Make sense?
Yep.
Make sense, Rosie? You're on mute.
Yes, it makes sense. I'm on mute because people are running and being loud upstairs. I don't want to be disrupted.
That's okay. Here, stay off mute for a minute because you're going to do
Okay.
the next one.
Okay.
We'll try one more here, and then we'll do the last lesson, which are just similar problems to all of these. So an eastbound bus left Ukiah at noon. Bus 1 and bus 2. Okay. 2 hours later, a westbound bus left the same station. If the buses traveled at the same rate and were 500 kilometers apart at 6 p.m., find the rate of each bus. So an eastbound left at Ukiah at noon, and it's asking about 6 p.m. So how long did it go?
Wait, can you say that again? Sorry.
So an eastbound bus left at noon, and it's asking about the distance at 6 p.m. So how
Okay, so-
long was it going?
So it left at noon and arrived at 6 p.m.
Yep.
That's. Wait, that would be 4 hours?
6 hours. Noon to 6.
Oh, yeah.
Okay.
What am I
2
thinking?
hours later, a westbound bus left the same station. So how long was that one going if it left 2 hours later?
Then it would be. It arrived at the same time?
Yeah, we're talking about the same time.
Okay, so, but it left 2 hours later?
Yep,
Then it would be there for 4 hours.
it'd be going 4 hours, right?
Yeah.
It said that the buses traveled at the same rate. So what will we put for rates?
don't know.
Just an R.
Oh yeah. Oh, I'm so stupid again.
There you
Yeah.
go. And now how do we get distances?
You have to do the like the time and isn't it like the time the time and the rate? There's do like 4. Wait, no, because what we did last time was the rate was like R plus 6 or so, or R plus
All
9.
you do is just multiply the time times the rate. So what do you
Okay,
get?
yeah, so 4R for bus 2 and 6R for bus 1.
There you go. Now, at the end of, at the 6 p.m., at the same time that we're talking about here, the two buses were 500 kilometers apart. So how would we write that into our equation? They went opposite directions and they ended up 500 kilometers apart.
I don't know how to write. How would you write that? Wait, no, because
So if they started here and they went opposite directions, that means
oh,
the length the first bus went plus the length the second bus went
that's
combined
6R.
equals that 500 kilometers.
So 6R plus 4R equals 500 kilometers.
You got it. So 6 plus 4 is?
10. So 10R equals 500.
Yep. And then
R equals 50.
there you go, 50 kilometers an hour.
Okay, that
Okay.
makes
Yep. Okay, try the practice problems on that one too. Let's do the last one now. Again, these are all the same basic types of problems. We'll go over these again on Wednesday, but I want you to try them before then, okay? So 99. We're now on lesson 99 there, Mark. Okay, this one is the same idea, except they have unequal distances. So you have to add something to one distance to equal the other. Okay, so let's look at 99.1. At 8 p.m., Achilles left camp and headed south at 20 kilometers an hour. At 10 p.m., Patroklos headed south from the same camp. If Patroklos was 50 kilometers ahead by 3 a.m., what was his speed? Okay, so 8 p.m. Achilles left, and we're talking about 3 a.m. So what is 3 a.m. or 8 p.m. to 3 a.m.? 9, 10, 11, 12, 1, 2, 3. That's 7 hours. Okay. Patroklos left 2 hours later at 10 p.m. So how long is from 10 to 3? So 10, 11, or 11, 12, and then 1, 2, 3. So it's 5 hours. Okay. You see how we get the time? Okay. See how we get the time there? For both of those? Yeah. Okay. Achilles headed south at 20 kilometers per hour. So the rate is just 20. It gives it to us. Right? Patroklos, it doesn't know. We're asking what its speed is. So let's do an R. Okay? Right? Now multiply rate times time to get distance. So 20 times 7 is 140. So that's Achilles' distance. Patroklos was 5 times R, 5R. That was his distance, okay? Do you guys get how we do the table? Thumbs up. Good. Okay. Now it says Patroklos was 50 kilometers ahead. So that means Achilles plus 50 equals Patroklos. So Achilles was 140 plus an extra 50 equals Patroklos, which is 5R. So that's how we set up that equation. 140 plus 50 equals 5R. You get how we did that? The 50 was listed in the word problem. That's why we added 50. So that was that there. Okay. So then we just add 140 and 50 to get 190 equals 5R, divide both sides by 5, and R equals 38. So Patroclus was traveling at 38 kilometers an hour. Make sense?
Yep.
Yep. Okay, great. How many do we have here? Okay, Bella, do number 99. Actually, no, Mark, do 99.2.
Okay. All right. Rachel has a 15-kilometer head start on Charlene. How long will it take Charlene to catch Rachel if Rachel travels at 70 kilometers per hour and Charlene travels 100 kilometers per hour?
Okay.
So, put 70 kilometers per hour in rate for Rachel.
In which box?
Rate.
Very good. 70 kilometers per hour,
And 100 for Charlene.
100 for Charlene. Then what?
Minus 15 kilometers in parentheses since Rachel had a 15-kilometer head start.
So when we're dealing with changes in distance, do it when we make the equation at the end, when we set the distances equal to each other.
Okay.
Okay. So they ran for, how would we express the time they ran?
They don't tell you how long.
Right. So that's going to be your variable.
Yeah.
Okay.
And then multiply rate times time, you get 70t, and distance and 100t.
Exactly. Now is when you figure in that 15 kilometer per hour or 15 kilometer head start. So who had the head start?
Rachel?
So we'd add 15 to her distance, right?
Yeah.
So, I mean, you can put it up here even if you wanted, plus 15, right? So that means 70t plus 15 equals,
Wait, why would you add it to her distance?
because she had a 15 kilometer head start. Think of a
Okay.
race. What does a head start mean?
It means she started earlier than the other opponent.
No, well, I mean, in this case, they both started at the exact same time. It means she started 15 kilometers ahead.
Oh, okay. Okay.
Okay.
Never mind, I get that.
Yeah. So there we go. So 70t. Right?
Yeah.
Okay. So then how would we solve this?
Subtract 70t from both sides.
Yep. You get what?
15 equals 30t.
Okay. Then what?
And then you just get t equals 2.
Nope.
What?
How do you isolate t? What's happening to t?
Subtract 30 from both sides?
No, not you had it right by dividing. You just divided wrong.
What did I do? 15.
You divided 30 by 15.
You divide 15 by 30?
Right. Because 30 is being multiplied by t. So to get t
So
by
could
itself,
t
you have to
equals
divide
0.5?
by 30. Equals what?
0.5?
Right, a half.
All right.
Right? So
Yep.
t is a half an hour. That's how long it would take.
All right.
Okay? Does that make sense?
Yep.
Okay, Rosie. You're going to have to come off mute because you get the last problem of the day.
Hooray.
Let me delete these real quick. There we go. Okay. So now we have Harry and Janet. Jog around a circular track that's 210 meters long. Janet's rate is 230 meters per minute, while Harry's is only 200 meters per minute. And how many minutes will Janet be a full lap ahead?
Okay.
So let me read it again. Janet's rate is 230 meters per minute.
All right.
So where would we put that?
Under rate on Janet's column or whatever.
230 meters per minute. Is that right? Meters per minute. Yeah. Well, Harry's rate is only 200 meters per minute. Where do we put that?
Right above that on the same thing.
Very good. That says, in how many minutes will Jenna be a full lap ahead? Okay, so what would the time be for either of them?
Wait, how long was the track?
That doesn't matter yet.
Oh, okay.
Right. It's saying how long, because they both started at the same time, and they're both going, or Janet is going to be one whole lap ahead at the same time. So both of these would be T,
Oh, yeah, yeah,
right? Does that make sense?
yeah.
There you go. Multiply. 230 meters per minute times T minutes gives you
230 T.
230 T meters,
Oh, yeah.
right?
meters.
And what about the top one?
200 T meters.
Very good. Now it's saying that the circular track is 210 meters long. So how long would it be before Janet has run an extra 210 meters? That's when they would go around one extra lap, right?
Mm-hmm.
Does that make sense?
Yeah.
Okay, so it'd be 200 T plus 210
Yeah.
equals 230 T. You guys get how we did that?
Yeah.
Okay, so now solve that. What would we do, Rosie?
You subtract 210.
Nope.
From-
Now leave it, it's positive. Leave it where it is.
Okay. Then you subtract 200 T from each side.
There you go. So
And
210 equals,
Wait, oh yeah, 210 equals 30 T.
very good. 21 divided by 3.
7.
There you go. So it took 7 minutes.
Wait, how did you get 21 divided by 3?
Well, because 210
210.
divided by 30. Think of it as a fraction here, like this. Equals the same as 21 over 30 times 10 over 10.
Oh, okay. Yeah, yeah.
Equals 21 over 30 times 1. No, not over 30, over 3. Yeah. That's how you got it. You could
Okay.
just divide 210 by 30 too. You know, it's just easier to go the other way.
Mm-hmm.
You got it?
Yep.
Yeah.
So it took 7 minutes,
Okay.
right?
Mhm.
Harry
Oh, that's right. Charlene was last.
was Rachel. Yeah. Yeah. The reason we added it is because Harry plus an extra whole lap would be as far as Janet went. Right? Does that
Yeah.
make sense?
Mm-hmm.
Okay. Well, there you go. Any questions or comments?
Nope.
Okay.